Hey guys, I'm sorry I'm not here today, but I thought I'd go ahead and record a video to help you guys go ahead and continue practicing your work with graphing and solving inequalities. So I thought about actually working out some of the examples from the worksheet that you were given, but I did not have a copy at home. So what I did was I chose some problems that I thought were similar to the ones on the worksheet, and we're going to work through these together. So for the video, you'll need to have out your note page from yesterday, and for every example that we do, I want you to make sure you have that in your notes. And we're going to start with going back, taking a step back to something you guys did last year and just reviewing it again. So what I suggest is go into your notes and without starting a new page, just putting this kind of as a subtitle. Oops, let me get a highlighter here. All right, so graphing inequalities, put that as your subtitle. And I have some inequalities right over here that we're going to go ahead and practice graphing. And I'm just going to do that in this space right here. So starting off, we're going to look at the inequality. N is less than or equal to 5. And for you folks who are still a little unsure about really what to do on this, I'm going to write the inequality over here, and you can just put down, example, and then put n is less than or equal to 5. And really what this means is n stands for any number. So if we read this inequality correctly, it's going to be read like this. Any number, n, is that's less than or equal to 5. All right, so in other words, this inequality, for this inequality, the solution set will be any number that is less than or equal to 5. Now, from yesterday, I called this the symbolic solution set or the algebraic solution set, and what I want you to do is to create a graph of that. So we're going to just make a number line, and the number line you see on your worksheets will be more complicated than the ones we make, but I told you there's two numbers that I want to see. I want to see 0, so draw this in your notes, please. And I want to see the cutoff number, which in this case will be 5. And 5 would be to the right of 0 on the number line. Now, one of the first things I like to do is start with the cutoff number of 5. And ask myself, does 5 make this inequality true? In other words, if I put 5 right here for n, will it make the inequality true? So in other words, is 5 less than or equal to 5? And the answer is yes. Yes, it is. So for the cutoff number, on the number line, I'm going to put a large point, and because it's included in the solution set, it makes this inequality true. We're going to shade it in. Something you should have learned last year in 7th grade. If not, well, then you're learning it for the first time now. Now, this inequality up here also represents numbers that are less than 5. So basically any number that's less than positive 5 will also make it true, like 4 or 3. And those numbers would be like right in here, 4 and 3, 2 and 1, and then all the numbers in between as well, all those decimals and stuff like that. So rather than put points on each individual solution that'll make this inequality true, we'll simply just shade, because after you get so many points, it's going to start to look like a solid line anyways. And any number, and that means even going down into the negatives, that makes this inequality true is part of the solution set. And that right there is your graph for that inequality. Okay, so I'm going to erase this one, and we're going to go on to the next one here. All right, so that brings us to r is greater than 2. So write that here for your next example, r is greater than 2. And if you listen to the way that I say that and you say it yourself correctly, it's pretty easy to figure out the solution set, And if you're like, well, how am I figuring out the solution set? What is he actually doing to figure out these numbers? Well, I'm just thinking about numbers that I could plug in here for r that would be greater than 2. And that would include numbers like 3, 4, 5, 6, 7, on and on and on. But rather than list them all out, because you can't, there's too many, we're just going to create a graph. So I'm going to make a number line. Kind of a fancy number line there. I'm going to put 0, and we'll put the cutoff number, which is 2. And again, I'm going to ask myself, the cutoff number, 2, does it make this inequality true? In other words, is 2 greater than 2? And the answer actually is no. So 2 will get a large point, but we're going to leave it open. We call that an open circle right there, okay, because 2 is not included. However, we just made a list, and we know that numbers that are greater than 2, when we plug them in for r right there, will make it true. So in which direction are the numbers greater than 2? And that'll be this direction. So that part of my graph is already pretty big, so I'm going to have to try to shade it. And we also usually color in the arrow that's over here. So there is my solution set, an open circle on 2, shaded to the right. All right, simple enough. We're now going to go on to the third example on graphing inequalities. And that'll be, let's see, pick a different color here. That'll be this one right here. K is less than or equal to -2. All right, so in this case, all numbers that are less than or equal to -2 will make this inequality true when we substitute them in for K. That would be numbers like -3, -4, -5, and then all the decimals in between. So there's a lot of solutions here. So again, we're going to make a graph because that's the easiest way to show the solution set. And I want the number 0 and the cutoff number. Now this time, because the cutoff number is -2, it's actually going to be to the left of 0 on my number line. So I'm going to have -2 to the left right here. And then I start off again by asking myself, does the cutoff number of -2 make this inequality true? If I plug in -2 for K, is -2 less than or equal to -2? And the answer is yes, it is. So I'm going to put a large point, and I'm going to close it. We call this a closed circle. Okay, it really doesn't have to be that big. I'm kind of overemphasizing it. And then any number that's less than -2, and that'll be in this direction. So we're going to shade the number line to show all the numbers that would make this inequality true. And there's your solution set, your graphical solution set. I forgot to mention, if at any time you need more time, just let the substitute know, and they can pause the video or rewind as well. And then lastly, we have -5 is greater than or equal to v. And this one's a little strange because you'll notice the variable is on this side. And here's what I highly, highly, highly recommend. So, you know, put a little star or something with this example. I would rewrite the inequality. Very, very important. Rewrite it. A lot of people get confused when they have a variable on the right. So what I would suggest is rewrite it. So now we have v. And notice the symbol originally, it's pointing towards the v. So when we rewrite it, it actually is still pointing. See that point right there? It's pointing towards the v. So we're going to make sure that that's still true, and we still have -5. Okay, very tricky. So rewrite, and then I'm going to draw a number line. Well, it ended up being red anyways, but that's okay. 0, and since we have a cutoff number that's negative again, we're going to have it over here to the left of 0. So at this point, we ask ourselves, does the cutoff number of -5, does it make the inequality true? So is -5 less than or equal to itself? And the answer is yes. So we're going to actually close that circle in because -5 makes it true. And the numbers that are less than -5 are in this direction over here. And there's our graph. So there are 4 quick examples of how to graph basic inequalities. And if you had trouble with last night's homework and need to go back and revisit those, do that here in just a few minutes and kind of reflect back on some of these examples that we just did. All right, we're now going to move on to the next video.